Hello and welcome. Tonight we are going to spend some quiet time together, thinking about something that has been showing up more and more in conversations about technology. The idea of AI agents. What they are, what they can do, and perhaps just as importantly, what they are not. There is no rush here. This is not a lecture you need to take notes on, and there will not be a test at the end. If you find yourself drifting off at any point, and I do mean any point, that is perfectly fine. That is, in fact, one of the nicest outcomes this conversation could have. The ideas will still be here if you want to come back to them another time. And if you stay awake through the whole thing, that is fine too. We will have a pleasant time either way. And before we go any further, a small question for you. Are you listening to relax, to study, or to fall asleep tonight? There is no right answer. Just notice it quietly for yourself. We are going to move through this gently, the way you might wander through a quiet museum on a slow afternoon. We will start by thinking about what the word agent even means. Not in technology, but in everyday life. Then we will take a little side trip to understand, at a very basic level, how the AI models underneath these agents work. From there, we will look at what makes something more than a chatbot. What gives it that quality people call agentic. We will look at real examples of what agents can do today, clear up some common misunderstandings, peek at the quiet infrastructure that connects these systems to the wider world. Think about how people keep them safe and trustworthy. And then, toward the end, we will gaze just a little way into the future, before letting the whole conversation wind gently down. So, settle in, get comfortable, and let us begin.
Section 1. What do we even mean by agent? Let us start with a word that most of us already know, even if we have never thought about it in the context of technology. The word is agent. If you have ever used a travel agent, you know what an agent does. You tell them where you would like to go, roughly when, maybe how much you would like to spend, and then they go off and do things on your behalf. They search for flights. They compare hotels. They check availability, negotiate rates, and come back to you with options. You did not have to call every airline yourself. You did not have to browse dozens of hotel websites. The agent acted for you, using their expertise and their connections to get something done. A real estate agent works in a similar way. You say, "I'm looking for a 2-bedroom apartment near the park, and here is my budget." And the agent goes out into the world and does things. They search listings, schedule viewings, talk to other agents, handle paperwork. They are acting on your behalf, within the boundaries you have set. An insurance agent, a literary agent, a talent agent. The pattern is the same. You have a goal. The agent understands that goal. And the agent takes actions in the world to help you move toward it. Now, there is something important tucked inside that pattern, and it is worth noticing because it will matter later. An agent does not just answer questions. A travel agent is not someone you call to ask, "What is the capital of France?" and they say, "Paris," and that is the end of the conversation. That would be more like an encyclopedia, or a search engine, or a helpful friend. An agent does things. They take actions. They make decisions along the way, small decisions, usually, within the boundaries you have given them. They might choose one airline over another because they know you prefer a window seat. They might book a hotel that is a little over your budget because it is in a much better location. They use judgment within limits. And there is another quality that agents tend to have. They work across multiple steps. Booking a trip is not a single action. It is a sequence. Find flights, compare them, check hotel availability near the destination, look at ground transportation, confirm the dates work together, and then present the whole package. The agent manages that sequence, keeping track of where they are in the process, adjusting if something does not work out. So when we talk about an agent in the everyday sense, we are really talking about something, or someone, that has a goal, can take actions in the world, can work through a sequence of steps, and can make small decisions along the way. Now, let us carry that idea very gently into the world of software. For a long time, most software worked in a very straightforward way. You clicked a button and something happened. You typed a search query and you got results. You filled out a form and it was submitted. The software did exactly what you told it to do, one step at a time, and nothing more. It did not interpret your intentions. It did not figure out the next step on its own. It did not adapt if something went wrong. In recent years, though, something has begun to shift. With the rise of artificial intelligence, and specifically the kind of AI that can understand and generate language, people started asking a natural question. What if we could build software that works more like an agent? Not software that just responds to a single command, but software that can take a goal, break it into steps, use different tools along the way, and work through the process with some degree of independence. That is, in essence, what people mean when they talk about AI agents. They are talking about AI systems that have been given the ability to do more than just respond. Systems that can plan, act, observe the results of their actions, and continue working toward a goal. But we are getting a little ahead of ourselves. Before we can really understand what makes an AI agent special, it helps to have a gentle sense of how the AI underneath actually works. And that is where we will turn next. So, to quietly gather up what we have covered so far, the word agent has a long history in everyday life. It refers to someone or something that acts on your behalf, takes multiple steps, makes small decisions, and works toward a goal. When people talk about AI agents, they are borrowing that same idea and applying it to software built on artificial intelligence. Section 2. The building blocks. How AI models work at a basic level. To understand AI agents, it helps to understand, at least in broad strokes, what is going on underneath. And the good news is that the core idea is surprisingly simple, even if the details get very complex. The kind of AI that powers most of today's agents is called a large language model. You may have heard that term before, or its abbreviation, LLM. Let us unpack it, slowly and simply. A language model is a system that has been trained to work with language, with words and sentences and paragraphs. It has read an enormous amount of text, books, articles, websites, conversations, scientific papers, instruction manuals, stories. Not all of the internet, but a very large and varied collection of written material. From all of that reading, the model learned patterns. Not in the way you or I learn things. It does not have memories of sitting down with a particular book, but in a statistical, mathematical way. It learned which words tend to follow which other words. It learned the shapes of sentences, the rhythms of explanations, the structures of arguments. It learned that if someone asks a question, what follows is usually an answer. It learned that if a paragraph begins with "however," What comes next will likely contrast with what came before. Think of it like this. Imagine you listen to thousands and thousands of conversations. After a while, you would develop a sense, not a perfect one, but a strong one, for what someone might say next in any given conversation. If someone said, "The weather today is really quite," you would have a good guess that the next word might be nice, or warm, or cold, or miserable. You would not know for certain, but you would have a feeling based on all those conversations you had absorbed. That is, in a very simplified way, what a language model does. Given some text, it predicts what comes next, and it does this remarkably well. Well enough that its predictions often look like thoughtful, coherent, knowledgeable responses. Now, the scale of this is worth appreciating, even if we keep it gentle. A modern language model does not just know that nice might follow, the weather is really quite. It has learned patterns at every level, from individual words and phrases, to the structure of sentences, to the flow of paragraphs, to the shape of entire arguments. It has, in a sense, absorbed the rhythms of human communication so thoroughly that it can reproduce those rhythms in response to almost any prompt. And there is something else that is worth noting. Because the model has been trained on such a vast range of text, it has been exposed to information about an enormous range of topics. It has read about history, science, philosophy, cooking, gardening, medicine, law, engineering, literature, and countless other subjects. It does not know these things the way an expert knows them. It does not have experience or intuition in any given field, but it has seen enough text about enough topics that it can produce plausible, often accurate responses on a remarkable variety of subjects. This breadth is part of what makes language models feel so capable. You can ask about the French Revolution, or how to make sourdough bread, or how photosynthesis works, and the model will produce a response that sounds knowledgeable and coherent. It is drawing on the patterns it learned from all of that training data, assembling its response one word at a time, always choosing the next word that fits best given everything that has come before. Now, there is a subtlety here that is worth pausing on, because it will matter when we talk about agents. A language model, on its own, is a bit like a very eloquent conversationalist who is sitting in a room with no windows and no phone. It can talk about the weather beautifully, but it cannot actually check the weather. It can describe how to send an email, but it cannot actually send one. It can explain how a calendar works, but it cannot look at your calendar. The model generates text. That is its core ability. It takes some input, your question, your request, your message, and it generates a response, one word at a time, based on the patterns it has learned. This is important to keep in mind, because when we start talking about agents, the key difference is not that the model becomes smarter in some fundamental way. The key difference is that the model is given the ability to do more than just generate text. It is given tools. It is given the ability to take actions. But the part where it chooses what to do next, the planning and step selection, still comes from the same kind of pattern recognition and prediction that the model was trained on. It is not thinking in the way a person thinks. It is following learned patterns to decide on the next step. Let me offer another gentle metaphor. Imagine a very thoughtful person sitting at a desk. They are excellent at reading, writing, and thinking. If you hand them a letter and ask for a reply, they will write a beautiful, well-reasoned response. But they are just sitting at a desk. They cannot go anywhere. They cannot make phone calls. They cannot check anything. Now, imagine you give that person a phone, a computer, and access to a filing cabinet. Suddenly, they can do much more. They can call someone to verify a fact. They can look up a record. They can send a message. They are the same person with the same thinking abilities, but now they have tools. And that changes everything about what they can accomplish. That is, roughly speaking, the difference between a language model on its own and an AI agent. The agent is the model, plus tools, plus the ability to decide when and how to use those tools. There is one more piece of the puzzle that is worth mentioning before we move on, and that is the idea of context. When you talk to a language model, when you send it a message, the model does not remember your previous conversations the way a friend would. Each conversation starts fresh. The model sees the current conversation, the messages going back and forth in this session, and it works with that. This is what people call the context window, the amount of text the model can see and work with at any given moment. Some models have larger context windows than others, which means they can keep track of longer conversations or larger documents. But the basic idea is the same. The model works with what it can see right now. For agents, context matters a great deal, because an agent that is working through a multi-step task needs to remember what it has already done, what the results were, and what it still needs to do. Managing that context, keeping track of the agent's progress, is one of the quiet challenges that designers of these systems have to think about carefully. So let us gather this up gently. A large language model is a system trained on vast amounts of text that has learned to predict what comes next in a conversation. It is very good at generating coherent, relevant text, but on its own, it can only talk. It cannot act in the world. When we give it tools and the ability to use them, we start moving toward what people call an AI agent. And managing the context, what the agent knows and remembers during a task, is an important part of making that work. Let us take a small breath here. We have covered some foundational ground, the everyday meaning of agent, and the basic mechanics of how language models work. Think of it as having laid a quiet path through a garden. We know where we started, and we can see the next gentle turn ahead. Somewhere outside, perhaps it is late evening, and the air has that particular stillness to it, the kind that settles in when the world is winding down. There is no hurry. Let us continue when you are ready. Section 3. From chatbot to agent. What makes something agentic? Now that we have a sense of what a language model is and how it works, we can ask a question that is at the heart of this whole topic. What makes something an agent rather than just a chatbot? A chatbot, in its simplest form, is a system that takes your message and gives you a response. You type something, it types something back. That is the end of the interaction. You might go back and forth several times, but each exchange follows the same basic pattern. You speak, it responds. And chatbots can be quite good at this. If you ask a chatbot a question, it can give you a thoughtful, well-structured answer. If you ask it to write something, it can produce a draft. If you ask it to explain something, it can do that too. Chatbots powered by modern language models are remarkably capable at this kind of back and forth. But there is a boundary. The chatbot responds to you. It does not go off and do things on its own. It does not open your email, check your calendar, search the web, run a calculation, and then come back with a plan. It does not take a goal and break it into steps and work through them one at a time. It waits for you to tell it what to do next. An agent, by contrast, can do more, and the difference comes down to a few key capabilities that, when combined, produce something qualitatively different from a chatbot. The first capability is perception. An agent can take in information from the world, not just your typed messages, but data from other sources. It might read the contents of a file, look at a web page, receive information from a database, or observe the results of an action it took previously. It has some way of sensing what is going on around it. The second capability is planning and step selection. Given a goal, an agent can determine how to break it into smaller steps. If you ask an agent to find me the best flight to Tokyo next month, it does not just generate a paragraph about Tokyo flights. It thinks about what steps are needed. Search for flights, compare prices and times, check for layovers, maybe look at your preferences if it has access to them, and then present the best options. It creates a plan, even if that plan is simple. The third capability is action. The agent can actually do things. It can call a search engine. It can query a database. It can send a message. It can create a file. It can click a button on a website. These are the tools we talked about earlier: the phone, the computer, the filing cabinet on the desk. And the fourth capability, which ties everything together, is the loop. This is perhaps the most important part. An agent does not just plan and act once. It plans, acts, observes the result, and then decides what to do next. If the first flight search did not return good results, the agent might try different dates or a different airline. If a file it tried to read was not available, it might look for it in a different location. The agent works in a cycle: perceive, think, act, observe, and repeat, until the goal is met or until it determines it cannot proceed. This loop is what people sometimes call the agentic loop, and it is the defining characteristic that separates an agent from a simple chatbot. A chatbot is a single exchange: input, output, done. An agent is a process: goal, plan, act, observe, adjust, continue. Now, it is worth saying that there is not a hard, bright line between a chatbot and an agent. It is more of a spectrum. A chatbot that can search the web before answering is a little bit agentic. A system that can use 3 different tools and chain them together is more agentic. A system that can work through a 10-step task, adapting its plan as it goes, is quite agentic. The word agent describes a tendency, a set of capabilities, rather than a strict category. There are a few other concepts that often come up when people talk about AI agents, and they are worth mentioning gently here. One is tool use. This is the idea that the model can call external tools: a calculator, a search engine, a database, a code interpreter, and incorporate the results into its planning. Tool use is what gives an agent its hands, so to speak. Without tools, the model can only think and write. With tools, it can do. The way tool use typically works is surprisingly simple in concept. When the model is generating its response and determines that it needs information it does not have, say the current price of a stock or the contents of a particular file, it generates a special kind of output that signals, "I would like to use this tool now." The system running the agent intercepts that signal, calls the appropriate tool, gets the result, and feeds it back to the model so it can continue. The model then incorporates that new information into its ongoing response. It is a little like a chef who pauses mid-recipe and says, "I need to know how much butter is left in the fridge." Someone goes and checks, comes back with the answer, and the chef continues cooking. The chef's skill has not changed. They are still the same chef. But now they have access to information they did not have a moment ago, and they can adjust their plan accordingly. Another is memory. We mentioned earlier that language models have a context window, a limited amount of information they can work with at any given moment. Agents often need to work on tasks that span longer than a single context window. So designers build memory systems that allow the agent to store and retrieve information over time. This might be as simple as a list of notes the agent keeps, or as complex as a database it can query. And a third concept is goal-directed behavior. A chatbot does not really have a goal in any meaningful sense. It responds to whatever you say. An agent, by contrast, has been given a goal, something it is trying to accomplish, and it orients its actions toward that goal. It can evaluate whether it is making progress. It can decide when it is done. It can recognize when it is stuck and needs to try a different approach. Let us tie this together with a quiet example. Imagine you are working on a project and you want to find out how your competitors are pricing a certain product. If you were using a chatbot, you might ask, "What is the average price of this kind of product?" And the chatbot might give you a general answer based on its training data, which may or may not be current. If you were using an agent, you might give it a slightly different kind of instruction. Search the web for the current prices of this product from these 5 competitors, compile the results into a table, and calculate the average. The agent would then search for each competitor's price, one at a time, collect the results, put them into a table, do the math, and present the final result. It worked through multiple steps, used tools, observed the results of each action, and delivered a completed task. That is the essence of what it means to be agentic. So, to softly recap, what separates an agent from a chatbot is the combination of perception, reasoning, action, and a loop that ties them together. An agent can take in information, make a plan, use tools to take actions in the world, observe the results, and continue working toward a goal. These capabilities exist on a spectrum, and different systems are more or less agentic, depending on how many of these qualities they have and how well they work together. Section 4. What AI agents can actually do today. Now we arrive at what might be the most interesting part of our conversation, at least for those who are still gently awake. What can AI agents actually do right now in the real world? Not in 5 years, not in some speculative future, but today. The answer, it turns out, is quite a lot, though perhaps not in the dramatic science fiction way that some headlines might suggest. The reality is more practical, more grounded, and, in its own quiet way, quite remarkable. Let us start with one of the most common and well-developed uses of AI agents: coding assistants. There are now AI tools that can help software developers write, test, and fix code. But the more advanced versions of these tools go beyond just suggesting a line of code. They can be given a task. Add a search feature to this application, or fix the bug that causes the page to crash when someone enters a long name. And they will work through the problem in multiple steps. They might read the existing code to understand how the application is structured. Then they might write some new code, run it to see if it works, read the error message if it does not, adjust their approach, and try again. They can execute commands, run tests, and iterate until the task is done. This is the agentic loop in action. Plan, act, observe, adjust. These coding agents are not perfect. They make mistakes, sometimes confidently. They can misunderstand the intent behind a request. They might change something that was working fine while trying to fix something that was broken. They work best when a human developer is reviewing their work, guiding them when they go astray, and confirming that the final result is correct. but they can handle a remarkable amount of the routine, mechanical work that goes into building software, freeing up human developers to focus on the harder, more creative problems. What makes these coding agents particularly interesting from our perspective is how clearly they demonstrate the agentic loop. The agent does not just write code and hand it over. It writes the code, runs it, sees what happens, reads the error messages if something goes wrong, reasons about what might have caused the problem, makes a change, and tries again. This cycle might repeat 3 or 4 or 10 times before the task is complete. Each cycle is a small act of perception, reasoning, and action, the very pattern we discussed earlier. Another area where agents have made real progress is customer service. Many companies now use AI agents that can do more than recite answers from a script. These agents can look up a customer's account, check the status of an order, apply a refund, update an address, or liaise with a human representative, all within a single conversation. They perceive the customer's request, plan what needs to be done, take actions in the company's systems, and respond with the results. The experience is not always seamless. These agents can still stumble on unusual requests or edge cases. But for routine interactions, they can handle much of the workflow from start to finish without explicit human intervention. A person remains available to review or intervene when tasks fall outside the agent's training or when decisions carry greater consequences. Research is another area where agents are proving useful. There are AI tools that can take a research question, search through academic papers, synthesize findings, identify key themes, and produce a summary. Some can search the web, read the contents of web pages, compare information from multiple sources, and compile their findings into a coherent report. Again, the results require human judgment. The agent might miss important nuances or give too much weight to a particular source. But as a starting point for research, these tools can save a remarkable amount of time. Now, let me tell you about a particularly interesting example that illustrates where agents are heading. There is an open-source project called OpenClaw, created by a developer named Peter Steinberger, that takes a somewhat different approach to the idea of an AI agent. Instead of building a separate application or interface, OpenClaw is designed to run locally on your own computer and to use messaging apps you already know, apps like WhatsApp, Telegram, Slack, and Discord, as its interface. What this means is that you can send a message to your agent the same way you would send a message to a friend. You might type, "Check my email and let me know if there is anything urgent," or "Search the web for reviews of this product and summarize what people are saying," or "Help me draft a reply to this message." The agent receives your request through the messaging app, works through the task using whatever tools it has access to, email, web browsing, file management, and then sends you the result, right back in the chat. There is something appealing about this approach. It does not require you to learn a new application or navigate a new interface. It meets you where you already are, in the messaging apps you use every day. And because it runs locally, on your own machine, it gives you a certain degree of control and privacy that cloud-based agents might not. OpenClaw is not the only project like this, but it is a good illustration of the creative ways people are thinking about how agents should interact with us. The technology underneath, the language model, the tool use, the agentic loop, is similar across many agent systems. But the way that technology is packaged and presented to the user varies enormously. And that variation is part of what makes this space so interesting right now. Beyond these specific examples, people are building agents for all sorts of practical tasks. There are agents that can manage your calendar, scheduling meetings by checking availability and sending invitations. There are agents that can monitor a website for changes and alert you when something important happens. There are agents that help with data analysis, taking a spreadsheet of numbers, running calculations, creating charts, and writing up a summary of what the data shows. There are agents that help with writing, not just generating a first draft, but revising, restructuring, checking facts, and adjusting tone based on feedback. There are agents that help with project management, tracking tasks, sending reminders, and summarizing the status of a project. And there are agents that help with personal tasks, like organizing files, sorting through old emails, or planning a trip. The common thread in all of these examples is the same set of capabilities we discussed earlier. The agent takes a goal, breaks it into steps, uses tools to take actions, observes the results, and continues until the task is done. It is also worth noting that the ecosystem around agents is growing rapidly. Developers are building frameworks and platforms that make it easier to create agents, to give them access to new tools, and to deploy them in different contexts. There is a great deal of experimentation happening, and the range of what agents can do is expanding month by month. But, and this is an important but, delivered as gently as possible, agents are not magic. They are software. They work within the capabilities of the models and tools they are built on. They can be impressive, and they can also be frustrating. They can handle routine tasks well and struggle with unexpected situations. They are tools, and like all tools, they work best when they are used thoughtfully, with an awareness of their strengths and their limitations. To gather this up, AI agents today can help with coding, customer service, research, email management, web browsing, data analysis, scheduling, and a wide variety of practical tasks. Projects like OpenClaw show creative approaches to making agents accessible through familiar interfaces like messaging apps. The ecosystem is growing quickly, and the range of what agents can do is expanding. But agents remain tools, impressive and useful, but not infallible. Let us rest here for a moment. We have traveled from the idea of a travel agent booking flights, through the inner workings of language models, past the agentic loop, and into the real-world things these systems can do today. It has been a gentle journey so far, and there is no hurry to continue. Imagine, if you like, the quiet hum of a building at night, the soft sound of air moving through vents, the distant ticking of a clock, the particular calm that comes when most of the world has gone to sleep. We are just having a quiet conversation, you and I, about something interesting. Whenever you are ready, we will move on. Section 5. What AI agents are not. A gentle myth clearing. We have spent some time talking about what AI agents are and what they can do. Now let us spend a little time on what they are not. And I want to be gentle about this, because many of the misunderstandings people have about AI agents are entirely natural. They come from reasonable places, from science fiction, from news headlines, from the way technology companies sometimes describe their products. The first thing worth clarifying is that AI agents are not sentient. They do not have feelings, desires, consciousness, or inner experiences. When an agent says, "I think the best option is," or "I would be happy to help with that," it is generating text that fits the pattern of a helpful response. It is not reporting on an inner state. It does not think in the way you and I think. It does not want anything. This is an easy thing to get confused about, and there is no shame in it. Language models are extraordinarily good at producing text that sounds like it comes from a thinking, feeling being. That is, in a sense, what they were trained to do: to produce responses that are natural, coherent, and contextually appropriate. But the naturalness of the output does not mean there is a mind behind it. There is a model, and it is doing math, very sophisticated math, operating over billions of parameters. But it is math nonetheless. The second clarification is that AI agents are not autonomous in the way that word is used in science fiction. When people hear autonomous agent, they sometimes picture a system that goes off on its own, makes important decisions without any human oversight, and acts independently in the world. The reality is much more bounded. Most AI agents today operate within carefully designed constraints. They have specific tools they can use and specific things they are allowed to do. They are typically supervised by humans, either directly, a person reviews and approves the agent's actions, or indirectly, through rules and boundaries built into the system. An agent that manages your calendar does not suddenly decide to start trading stocks. An agent that helps with coding does not wander off to write poetry unless you ask it to. The level of autonomy varies, of course. Some agents are given more freedom than others. But even the most autonomous agents are operating within boundaries set by their designers and users. They are not free-roaming digital entities with their own agendas. They are software systems that execute within defined parameters. The third clarification is that AI agents are not infallible decision-makers. They make mistakes. Sometimes they misunderstand what you are asking for. Sometimes they take an action that does not produce the expected result. Sometimes they get stuck in a loop, trying the same approach over and over without making progress. Sometimes they confidently present information that is incorrect. This is not the kind of issue that disappears simply because a new model release arrives. It is a fundamental characteristic of systems based on statistical prediction. Language models are probabilistic. They generate responses based on what is most likely, given their training data. Most of the time, the most likely response is also the correct one. But not always. And when agents take actions in the world based on those predictions, mistakes can have real consequences. This is why human oversight remains so important. The most effective agent systems are designed with the understanding that the agent will sometimes be wrong, and they include mechanisms for catching and correcting those errors. We will talk more about this in our section on guardrails and safety. The fourth clarification, and perhaps the most subtle one, is that AI agents do not understand the world the way you and I do. When an agent reads a document and summarizes it, it is not comprehending the meaning in the deep, experiential way that a human reader does. It is processing patterns in text and generating a response that is statistically likely to be a good summary. The result can be excellent, genuinely useful and accurate, but the process is different. An agent does not know what it is like to read a book on a rainy afternoon. It does not have the context of lived experience that informs human understanding. It works with text, and it is very, very good at working with text. But working with text and understanding the world are different things, and it is worth keeping that distinction in mind, even when the agent's output is so good that the distinction seems hard to see. There is a related point that is worth making gently, and it has to do with the way agents present information. Because language models are designed to produce coherent, confident-sounding text, an agent can sometimes present incorrect information in a way that sounds perfectly authoritative. It does not hedge or hesitate the way a person might when they are unsure. It does not say, "I'm not really sure about this, but," unless it has been specifically designed to do so. This is sometimes called the problem of overconfidence, and it is one of the reasons that human oversight remains so important when working with agents. If a friend told you something with complete confidence, you might take it at face value. But if you knew that your friend was sometimes confidently wrong, not out of dishonesty, but simply because that is how they are wired, you would learn to double-check the things that matter most. The same principle applies to working with agents. They are helpful and often accurate, but it is wise to verify the things that are most important to you. None of this is meant to diminish what agents can do. They are genuinely useful, often impressively so. But understanding their limitations is just as important as understanding their capabilities, because it helps us use them well. A tool works best when you understand both what it is good at and where it might fall short. So, to recap softly, AI agents are not sentient. They do not have feelings or consciousness. They are not autonomous in the science fiction sense. They operate within designed boundaries. They are not infallible. They make mistakes, sometimes confident ones. And they do not understand the world the way humans do. They work with patterns in text, which is powerful, but different from lived understanding. All of these are natural, understandable things to be unclear about, and there is no fault in having assumed otherwise. Section 6. The quiet infrastructure. How agents connect to the real world. We have talked about what agents can do and what they cannot do. Now let us talk about something that does not get as much attention, but is just as important. How agents connect to the outside world. Because an agent, no matter how clever, is not very useful if it is sitting in a room with no doors. The way agents interact with the world outside themselves is through something called an API, which stands for Application Programming Interface. Now, that sounds technical, and the name is not particularly friendly, but the idea is simple. Think of an API as a doorway with a very specific set of rules. If you want to come in, you have to knock in a particular way, state your business, and wait for a response. The rules are clear, predictable, and the same for everyone. An API is how one piece of software talks to another piece of software. When an AI agent needs to check your email, it does not log into your email account the way you would, with a browser and a password and a visual inbox. Instead, it uses an API, a structured, behind-the-scenes connection that lets it say, in effect, "Give me the 10 most recent emails," and receive the information back in a tidy, organized format. When an agent needs to add an event to your calendar, it uses a calendar API to say, "Create an event on Thursday at 3 o'clock with this title," and the calendar system does the rest. APIs are everywhere in modern software. They are the quiet plumbing that connects different systems together. Your weather app uses an API to get forecasts. Your banking app uses an API to check your balance. Your map application uses APIs to find directions, traffic conditions, and nearby restaurants. For agents, APIs are essential. They are the tools on the desk, the phone, the computer, the filing cabinet. Each API gives the agent access to a different capability: email, calendar, web search, file storage, databases, messaging, and so on. The more APIs an agent has access to, the more it can do. There is something almost elegant about the way this works, even if it is entirely invisible to most people. When you ask an agent to check your email, a quiet chain of events unfolds behind the scenes. The agent's control logic determines that it needs to access email. It formulates a request in exactly the format the email API expects. It sends that request. The email service receives it, checks that the agent has permission, retrieves the information, and sends it back in a structured format. The agent reads the response, incorporates the information into its planning, and continues with the task. All of this happens in a fraction of a second, and you never see any of it. You just see the agent tell you about your latest emails. This kind of invisible infrastructure is something we encounter all the time in our daily lives, even if we do not think about it. When you flip a light switch, you do not think about the power grid, the transformers, the substations, and the generating plants that make it possible. The infrastructure is there, working quietly, and the experience is effortless. The infrastructure behind AI agents is similar, a layer of quiet complexity that enables a simple, seamless experience. Now, here is where things get a little more interesting and a little more recent. One of the challenges with connecting agents to the world through APIs is that every API is a little different. The email API has its own rules and its own way of organizing information. The calendar API has a different set of rules. The database API has yet another. For an agent to use all of these tools, someone has to write specific instructions, called integrations, for each one. And as the number of tools grows, the number of integrations grows too, and things start to get complicated. This is a familiar problem in the history of technology. It is the same kind of problem that led to the creation of standards, agreed upon ways of doing things that make it easier for different systems to work together. Think of how electrical outlets are standardized in each country, or how USB connectors provide a common way to plug in devices. Standards reduce complexity by giving everyone a shared language. In the world of AI agents, a similar kind of standardization is beginning to emerge. One example is something called the Model Context Protocol, or MCP. It is an open protocol, a shared set of rules that makes it easier for AI models to connect to external tools and data sources. Let me offer a metaphor here. Imagine a large office building with many departments: accounting, human resources, legal, engineering. Each department has its own expertise and its own files. Now, imagine you are a new employee and you need information from several departments to do your job. If every department has its own unique way of handling requests, accounting wants you to fill out a blue form, HR wants an email, legal wants a phone call, engineering wants a message on a specific app. Your life is going to be complicated. But now imagine that the building has a central messenger service. You write a request on a standard form, hand it to the messenger, and the messenger knows how to deliver it to the right department and bring back the response. The messenger speaks every department's language, so you do not have to. That is roughly what MCP does for AI agents. It provides a standard way for an agent to say, "I need to access this tool," and for the tool to respond in a format the agent understands. By 2026, there are several major protocols in this space. The Model Context Protocol, or MCP, focuses on connecting agents to tools and data sources. Google's Agent-to-Agent protocol, known as A2A, focuses on letting multiple agents coordinate with each other. And it now also incorporates IBM's earlier Agent Communication Protocol, or ACP, which the two teams merged under the Linux Foundation. MCP is one example of this pattern. There are other approaches and function calling conventions, and the standards continue to evolve. This might sound like a small thing, but it has significant implications. When connecting an agent to a new tool becomes easier and more standardized, the range of things agents can do expands much more quickly. It means that a developer building a new service say a project management tool or a customer database, can make that service available to AI agents by implementing the standard protocol, rather than building custom integrations for every agent system separately. MCP is still relatively new, and it is one of several efforts to address this problem. But it represents an important direction, making the infrastructure for agents more interoperable, more consistent, and more accessible. There is another aspect of this quiet infrastructure worth mentioning, and that is the idea of permissions. When an agent connects to your email or your calendar or your files, it is given certain permissions, specific things it is allowed to do. Maybe it can read your emails but not send them. Maybe it can view your calendar but not delete events. Maybe it can search your files but not modify them. These permissions are an important part of how agents are designed to be safe and trustworthy. They ensure that the agent can only do what it has been explicitly allowed to do. If an agent does not have permission to send emails on your behalf, it simply cannot do that, no matter what anyone asks it to. We will talk more about safety and trust in the next section, but for now, it is worth appreciating the quiet, careful engineering that goes into connecting these systems to the world. It is not glamorous work. APIs, protocols, permissions, integrations. But it is the foundation on which everything else is built. Without it, agents would be brilliant conversationalists with nothing to do. To gather up, AI agents connect to the world through APIs, structured doorways that let software talk to other software. Every tool an agent uses, email, calendar, web search, databases, is accessed through an API. Standards like the Model Context Protocol are making it easier to connect agents to new tools by providing a shared language for communication. And permissions ensure that agents can only access what they have been allowed to, which is a quiet but essential part of the system. We are past the halfway point now, and we have covered quite a bit of ground together. We have thought about what agents are, how the models underneath them work, what makes something agentic, what agents can do today, what they are not, and the quiet infrastructure that connects them to the world. If you are still with me, thank you for the company. If you have drifted off, that is lovely too. There is something pleasant about the idea that these words are floating gently through the room, even if no one is listening. Imagine, perhaps, the soft blue glow of a screen in a dark room, the gentle whir of a fan somewhere nearby, the kind of quiet that is not really silence, but a kind of gentle background hum that the world makes when it is at rest. Let us continue, gently. Section 7. Guardrails, Safety and Trust. We've talked about what agents can do, and we have talked about how they connect to the world. Now let us talk about something that matters a great deal. How do we make sure they do it safely? This is a topic that can easily become alarming if handled poorly, and I want to be careful not to do that. The truth is that the people building agent systems, the researchers, engineers, and designers, are thinking about safety very seriously, and they have developed a number of thoughtful approaches. Safety is not an afterthought in agent design. It is woven into the fabric of how these systems are built. Let us start with one of the most important concepts in agent safety: the human in the loop. This is exactly what it sounds like: a design pattern where a human being is part of the agent's decision-making process. Rather than allowing the agent to take every action independently, the system is designed so that certain actions require human approval. For example, an agent that helps manage your email might be allowed to sort your inbox and draft replies on its own. but actually sending those replies might require your explicit approval. The agent does the work, but you make the final call. This gives you the benefit of the agent's capabilities while maintaining control over the actions that matter most. The human-in-the-loop pattern is flexible. It can be applied to some actions and not others, depending on how consequential the action is. Reading a file is low stakes, so the agent can do that freely. Deleting a file is higher stakes, so that might require a human to confirm. Sending money is very high stakes, so that would almost certainly require human approval, if it were allowed at all. Another approach to safety is the use of permission systems, which we touched on briefly in the infrastructure section. Permissions define what an agent is allowed to do and what it is not. These boundaries are set by the designers of the system, by the administrators who deploy it, and sometimes by the users themselves. Think of it like giving someone a set of keys. You might give them the key to the front door, but not the key to the filing cabinet. You might give them a key to the guest room, but not to the master bedroom. Each key represents a specific permission, and the set of keys the agent holds determines the scope of what it can do. Permission systems are important because they provide a hard boundary on the agent's capabilities. Even if the agent's control logic goes wrong, even if it decides, based on its pattern matching, that it should take an action it was not supposed to, the permission system will prevent it from doing so. The agent can want to open the filing cabinet all it likes, but without the key, the cabinet stays locked. A third layer of safety comes from content filtering and output monitoring. Agent systems often include checks on what the agent produces, both the text it generates and the actions it tries to take. If the agent generates content that is inappropriate, or if it tries to take an action that violates its rules, these checks can catch the problem before it reaches the user or the outside world. It is worth acknowledging, honestly and without alarm, that safety in agent systems is an active area of work. The field is still relatively young, and new challenges emerge as agents become more capable. For instance, as agents are given access to more tools and more data, the potential consequences of mistakes or misuse grow larger. An agent that can only generate text has a limited blast radius, so to speak. An agent that can send emails, access databases, and interact with external services has a larger one. Security researchers have identified legitimate concerns around what happens when agents are given broad permissions. If an agent can execute code, access the internet, and interact with multiple services, it is important to ensure that those capabilities cannot be exploited, either by malicious instructions hidden in the data the agent processes, or by adversaries who find ways to manipulate the agent's behavior. The response to these challenges has been thoughtful and multi-layered. Designers are building systems with defense in depth, multiple layers of protection, so that if one layer fails, others are still in place. They are developing better ways to test agents for vulnerabilities before they are deployed. They are creating standards and best practices for how agents should handle sensitive data. And they are engaging in open research, sharing their findings with the broader community so that everyone can benefit from what has been learned. There is also an important role for transparency. The best agent systems are designed to be transparent about what they are doing and why. They tell you what actions they are about to take and ask for your confirmation. They show you their reasoning, or at least a summary of it. They make it possible for you to understand what happened if something goes wrong. This transparency is not just a nice to have. It is essential for trust. You are more likely to trust a system that explains what it is doing than one that operates as a black box. And trust is, ultimately, what determines whether people will use these systems and whether those systems will be beneficial. It is a little like the relationship between a pilot and an autopilot system. The autopilot does a great deal of the work, but the pilot always knows what the autopilot is doing, can see its decisions, and can take over at any moment. The pilot trusts the autopilot because the autopilot is transparent, because the pilot understands its logic, and because the pilot knows they remain in control. Agent designers are working toward a similar kind of relationship between agents and the people who use them. There is also the matter of testing. Before an agent system is deployed, before it is given access to real email accounts, real calendars, real databases, it goes through extensive testing. Developers simulate different scenarios, try to find edge cases where the agent might behave unexpectedly, and refine the system until it handles those cases well. This testing is never truly complete. There are always scenarios that no one anticipated, but it reduces the likelihood of problems and helps developers understand the boundaries of what the system can handle reliably. The picture that emerges is one of careful, layered design. Human-in-the-loop patterns, permission systems, content filtering, security measures, testing, transparency. All of these work together to create an environment where agents can be useful without being dangerous. It is not a perfect system. No safety system ever is. But it is a serious, thoughtful, and evolving one. To recap gently, agent safety is built on multiple layers. Human oversight, permissions that limit what agents can do, content filtering, security measures, and transparency. Designers take these challenges seriously, and the field is actively developing better tools and practices. There are real concerns, particularly around broad permissions and potential vulnerabilities, but they are being addressed with careful, multi-layered approaches. Section 8. Where this is all gently heading. We've come a long way in our quiet conversation, and now we arrive at the question that naturally follows everything we have discussed. Where is all of this going? I want to be careful here, because predictions about technology have a habit of being either far too cautious or wildly overblown. I'm not going to tell you that agents will transform every aspect of your life by next Tuesday. And I'm not going to tell you that this is all hype and nothing will change. The truth, as it so often is, lies somewhere in the middle. In the gradual, steady kind of progress that does not make for exciting headlines, but does, over time, add up to something meaningful. One direction that seems fairly clear is that agents will get better at working together. Right now, most agent systems are designed to work alone, a single agent working on a single task. But there is a growing interest in what people call multi-agent systems, where several agents collaborate on a more complex problem. Imagine a team of agents, each with a different specialty. One is good at research, finding information, reading documents, synthesizing facts. Another is good at writing, turning raw information into clear, polished prose. A third is good at analysis, taking data, running calculations, spotting trends. And a fourth is good at coordination, managing the workflow, making sure each agent has what it needs, and assembling the final result. This is not science fiction. Researchers and developers are actively building systems like this, and early results are promising. The idea is that by dividing a complex task among specialized agents, each agent can focus on what it does best, and the overall result is better than what any single agent could produce alone. You might think of it the way a small company works. No single person does everything. The accountant handles the finances, the designer handles the visuals, The writer handles the words, and the project manager makes sure everyone is on track. Each person is good at their particular thing, and the final product, a finished campaign, a shipped product, a completed project, is the result of their collaboration. Multi-agent systems aim for something similar, with each agent playing a specific role in a larger workflow. Another direction is better memory. As we discussed earlier, current language models have a limited context window. They can only keep track of so much information at once. For agents working on long, complex tasks, this is a real limitation. But there is a great deal of work being done to improve how agents manage memory, storing important information, retrieving it when needed, and maintaining a coherent understanding of a task, even as it unfolds over many steps or even multiple sessions. Better memory would allow agents to be more like the human agents we started with. The travel agent who remembers that you prefer window seats, or the real estate agent who remembers that you mentioned wanting a garden. It would make interactions with agents feel more natural and more productive, because the agent would have a richer understanding of the context in which it is working. A third direction is more reliable reasoning-like processes. Current language models often exhibit reasoning-like behavior, but they are not perfectly reliable. They can make logical errors, miss important details, or reach conclusions that do not quite follow from the evidence. Improving the reliability of these reasoning-like processes, making agents more consistently accurate in their pattern-based planning, is one of the most important challenges in the field. There are several approaches being explored. Some involve giving agents the ability to check their own work, to reason about a problem, then go back and verify that their reasoning was sound. Others involve using specialized models for specific types of reasoning, mathematical reasoning, for instance, or causal reasoning. Still others involve combining the strengths of language models with more traditional, rule-based systems that are very reliable within their specific domains. And a fourth direction, perhaps the quietest one, is in the infrastructure. The tools, protocols, and standards that connect agents to the world are getting better, more standardized, and more secure. This may not sound exciting, but it is the kind of progress that enables everything else. When it becomes easier, cheaper, and safer to connect an agent to a new tool or a new data source, the range of useful things agents can do expands naturally. We talked about the Model Context Protocol earlier as one example of this kind of infrastructural progress. There are others: improvements in authentication and security, better ways to manage permissions, more robust methods for monitoring agent behavior, and evolving standards for how agents should interact with users and with the world. The overall trajectory is one of gradual improvement along multiple dimensions: better collaboration, better memory, more reliable reasoning, and more robust infrastructure. None of these improvements will arrive all at once, and none of them will be perfect. But taken together, over time, they will make agents more capable, more reliable, and more useful. It is worth ending this section with a note about pace. Technology often seems to move in dramatic leaps. A new product is launched, a breakthrough is announced, a headline declares that everything has changed. But the reality of progress is usually more gradual. Each improvement builds on the ones that came before. Each new capability opens up new possibilities, which in turn reveal new challenges, which in turn drive new improvements. It is a cycle, and it is a patient one. AI agents are on that cycle now. They are useful today, and they will be more useful tomorrow, and more useful still the day after that. Not because of any single breakthrough, but because of the steady accumulation of small improvements by thousands of researchers, engineers, and developers working on different parts of the problem. And there is something reassuring about that steadiness. The most durable progress in technology has always come not from sudden leaps, but from the patient, methodical work of making things a little better, a little more reliable, a little more useful, one step at a time. That is the kind of progress we are seeing with agents, and it is the kind of progress that, in the long run, tends to serve us well. So, to softly sum this up, the near future of AI agents involves better collaboration between multiple agents, improved memory that allows agents to maintain context over longer periods, more reliable reasoning, and stronger infrastructure for connecting agents to the world. The pace of progress is steady rather than revolutionary, and each improvement builds on the ones before it. And so we arrive at the end of our conversation, or at least the end of what I have to say. Let us let it wind down the way a conversation does late at night, when both people are comfortable, and there is no particular reason to keep going, except that it has been pleasant. We started with the simplest possible idea, that an agent is someone or something that acts on your behalf. A travel agent, a real estate agent, someone who takes your goal and works toward it, making decisions along the way. That idea, it turns out, maps quite naturally onto what people are building with artificial intelligence. Underneath it all, there is a language model, a system that has learned, from reading an enormous amount of text, to predict what comes next. It is good at generating language, at following patterns to solve problems, and at following instructions. But on its own, it can only talk. It cannot act. The magic, if we want to call it that, though it is really just engineering, comes from giving the model tools. A way to search the web, a way to read files, a way to send messages, a way to check a calendar or update a database. When the model can use tools, and when it can work in a loop, plan, act, observe, adjust, it becomes something more than a chatbot. It becomes an agent. Today, agents can help with coding, customer service, research, email, scheduling, and many other practical tasks. Projects like OpenClaw show creative ways of making agents accessible through the messaging apps we already use. The ecosystem is growing, the tools are getting better, and the range of possibilities is expanding. But agents are not magic, and they are not sentient, and they are not infallible. They are software systems, built by people, operating within designed boundaries. They make mistakes. They have limitations. And using them well means understanding both their capabilities and their constraints. The infrastructure that connects agents to the world, the APIs, the protocols, the permission systems, is getting more standardized and more secure. And the safety measures that protect us, human oversight, permissions, content filtering, transparency, are being developed with care and seriousness. The future holds steady progress, better collaboration between agents, better memory, more reliable reasoning, more robust infrastructure. Not a revolution, but an evolution. The kind of slow, steady improvement that, looked at over years, adds up to something remarkable. And that, I think, is a good place to let this conversation rest. If there is one thought to carry with you, into sleep, or into tomorrow, or into the next time you hear someone talking about AI agents, it might be this. An agent is a helper. It is not a mind. It is not a replacement for human judgment, and it is not a revolution happening overnight. It is a helper, a new kind of tool that can take a goal, work through steps, use other tools, and report back. Like all helpers, it works best when you understand what it can and cannot do, and when you stay involved in the parts that matter most. The technology will continue to improve, quietly and steadily. The agents of next year will be better than the agents of today. The agents of the year after that will be better still. And through it all, the fundamental idea will remain the same. Something that acts on your behalf, within boundaries you have set, toward a goal you have chosen. Thank you for spending this time with me. Whether you heard every word or drifted off somewhere in the middle, I hope it was a pleasant way to spend the evening. The world of AI agents will still be here tomorrow, moving forward quietly, one small improvement at a time. Good night.